Good day. This is Ward Harriman, AE6TY. I'd like to spend a few minutes, actually many minutes, talking about the new features of version 16.1 of SimSmith. The introductory video touched on a few things concerning compatibility with the past versions of SimSmith, and I would only like to point out a couple of really quick things that were probably not mentioned before, and if you are an advanced user, you will probably want to know. I'd like to encourage those of you who have not used advanced features of SimSmith before to at least view this video and get an idea of the kinds of analysis SimSmith can do for you. And maybe you'll see some new circuit ideas and some new analysis techniques that will help you use SimSmith to your advantage. The first thing is in F blocks. If you are an F block user, you will notice that the default value for an F block is now Zn. It used to be I. I was freed up to talk about the current flowing through an element, so I had to replace it with something in Zn1. If you've used F blocks in the past, you'll have to go through and hand translate all your F blocks. There's no automatic translation of F blocks. You saw in the earlier video that there is some automatic translation available for RUSE blocks, and what really happens is that when you put in a parameter or put in a component in the past, the default value down here, this dash, was translated into a parameter name which had the same name as the location. And SimSmith no longer allows you to have it finds confusing identifiers used for two purposes. So here the identifier is used as location, so you can't use it as a parameter name. The default convention in SimSmith now is to use the default location or use the location name and simply append an underscore to the end of it. You'll notice that when I did that, I got an error over here, and that error frame will stick around until you clear it or until you commit. I'm just going to commit. Now, one of the things that was talked about earlier is that the values of parameters in SimSmith version 16.1 are maintained with the full double precision of the machine. That's an IEEE floating point standard. And what you see is simply the rounded version of it. You can play with how many digits might be displayed. Right-clicking on this, you can set the number of digits. I'm going to set it quite high. You'll notice that it doesn't show all those digits, and SimSmith truncates trailing zeros when possible in order to keep the text as large and readable as possible. But those digits are still there, and if I, for example, do a shift control, which is the finest precision you can do, and I'd say down arrow, you'll see that all those digits appear. I can keep going, I can go back up. You'll see that it keeps rounding and truncating trailing zeros. Again, it's trying to keep the text as large as it can keep it. And the good news is, with carrying around double precision, down and up add up to 0, which didn't used to be the case, but it is now. The other thing that SimSmith 16.1 has added to the parameters is that most parameters can now be complex. So for example, I can say 50 plus J4, or here we go. And when you type that in, it will set the R and the X to be those values. And you can do this with nearly anything, including, for example, the center of the circle. And when you do that, you'll see that the center of the Smith chart is no longer 50 pure real ohms. It has a reactance. The display's a little ugly, but you're asking it to do an ugly thing. When you do this, I would warn you that your intuition concerning Smith charts will be wrong. Things will go outside the unit circle. All sorts of manner will be confusing. So when you do this, be extra diligent in deciding whether SimSmith is doing the right thing or not. I showed in the previous video a little bit of the text editing block. Here's the default block. Again, it lets you adjust the size of the fonts, and error messages generally come up right above here, and those error messages will persist until you get rid of them. Now you'll notice that the frame stays up here, and this is to keep it from bouncing up and down while you're typing. It got to be pretty annoying. And it will stay that way until you either commit or you clear the airframe, which you can do by clicking on this button down here. This doesn't happen too much. Generally speaking, it delays bringing up the airframe so that it doesn't annoy you while you're typing, and once it brings it up, it leaves it up again to not annoy you. Now, one of the important things that SimSmith 16.1 added was there was a growing use of SimSmith to do basic, almost SPICE-like simulations, and this is one of the nice things about SimSmith now is you can do almost arbitrary kinds of circuits in SimSmith by using a RUSE block. And one of the problems with doing this was when you were looking at the circuit, in order to look at the voltages or the currents or whatever floating through here, you had to know the names, the conventions, and you had to go down here to the plot menu, and you had to type in things like plot A.C1.P. So that was the sort of thing you had to know all the little piddly things in here. You had to know the name and the component name and the values. That gets to be a complicated process, and it really didn't aid in simulation. It was just a hoop you had to jump through. This is no longer the case. If you come down here to a component and you right-click on it, you'll get a menu of all the things that SimSmith knows how to generate the plot commands for. So for example, if I wanted to see the current flowing through this inductor, I would right-click on it and we'll say I want to see the wave of the current flowing through that inductor. I'm done. And you'll see down here on the square chart that the waveform has cropped up. You can do this for other things, of course. Probably not a lot of current flowing through this capacitor since it's 0 picofarads. So anyway, the point is you can now use this much more like SPICE, in that you can come and plot all the different parameters or all the different properties of these components on the waveform display or on the Smith chart, as it turns out. If I right click on this, you'll see I have the ability to plot various things on the Smith chart. So just to be aware of that, play with that a little bit. It makes the RUSE block much more usable as a general circuit simulator. One of the other features I added was in version 16.1 AA. Make sure you get the most recent version of anything if you're looking at my videos. this video, as it turns out, is AC because I fixed a bunch of little annoying things. So the letter things are minor bug fixes or aesthetic fixes. They don't really bring more features, but it's important to make sure you download the most recent thing. One of the things I did as I got started saying is that I provided for control select to delete components. This was something that didn't happen before. It is the same as deleting a component on the main circuit, and people kept going back and forth between the two, and it's nice when the control features work the same on the main circuit and in the RUSE block. Now, probably the most sophisticated thing that happened in version 16.1 is the introduction of the daemon block. And the daemon block is an extremely powerful mechanism. It is the incarnation of the new expression parser, which was the major effort in 16.1. The expression parser is what's responsible for the speed up in simulation and I want to say making orthogonal all the different naming conventions in the software. So when I ran into a problem where here's an identifier that's used in multiple ways in multiple places, I basically stamped out that practice. As I said, the daemon block is an incarnation of the expression parser. It is the same parser everywhere. It's just the daemon block is probably the place where you write the most complicated things. The daemon block, or the expression parser, I should say, now supports all manner of things. It supports functions and strings and plotting and printing. Basically, it gives you access to the internals of SimSmith. And keeping track of the internals of SimSmith can be a daunting task because they expand as time goes on. And there are times when you'd like to know, but you can't remember what the name of something is. So suppose there was something about let me add a block here. Suppose there was something about C1 that you wanted to plot, but you couldn't remember what it was. You can now just say C1, and when you type question mark says print whatever value was most recently computed. So in this case, the value is everything known about C1, and I want to print that out. And here is a list of all the things that are known about C1. There's the value F, you can see right there. There's the Q, there's the frequency of the Q, there's the reverse voltage, the reverse current, the inverse voltage, the inverse current. Probably should change the order of these to make them the most common ones first. But in any event, you can see these are all the things that SimSmith knows about and can plot or access, or in some cases update, about C1. So for example, here I could say C1.f is equal to 100 picofarads, and you'll see that it was set to 100 picofarads. I could say C1Q is equal to 10. I can set the frequency. If I try to set something that can't be set, it says no, Z is a read-only thing, and you can't assign it. As I said, SimSmith now lets you have strings and lets you do prints. So for example, this is, you saw earlier, you could do a question mark to print something out. So I could say dog question mark, and it will print out dog. It says it did it 5 times because this block was actually executed or evaluated 5 times. And another video I'm planning to do will talk about how SimSmith does all its internal calculations. So you'll see this 5 times or 20 times or 1,000 times if you're doing a sweep, or 10,000 times. Prints are not something you want to do during sweeps. They take up lots of time in the computer, and they end up with big text buffers that are difficult to maintain. You can also print out into the air frame and this is useful. So for example, you could say if C1.P is greater than 1 milliwatt, notice that I had a print up here that was in air, and I cleared the air. And now, it's saying if the power in this capacitor is greater than 1 milliwatt, I want to print this, and if I commit it, you'll see it keeps coming up. That wasn't very useful. Let me put a more interesting thing here. And I'll just leave this up. And here we'll see that when the Q is big enough, there is no air. And again, you saw that the airframe was persistent until I said clear air. So that's a way you can check to make sure that your circuit components are not being overly stressed, and gives you a way to print out things when you know that there's a problem with your circuit. Another good use of the daemon block is to say, let's do a plot. Now there's a new plot command. I can just say plot d1 dot, oh, let's do it differently. Let's do a wave of d1. Notice the capitalization, it's different. d1 dot, about the wave of I. And here we have a waveform of the current flowing through the daemon block. And I'm going to name this differently. I'm going to say this is a scope. And I'm going to get the wave of I and the wave of V. And I'm going to say it's type V and it's on the Y1 axis. And here I'm going to say it's of type I and it's on the Y2 axis. And let's turn off all these guys. And here I have the current and the voltage that's going through the I block. And I can, in fact, if I put in another inductor here, and I want to just move this, I'm going to name this scope. I just want to move this around, I can get the different waveforms that are going through that particular component. So I can basically move my scope probe around by writing this block And I could add, of course, add other things, power of P. And we'll see now that there's a P down here, power. So that's the power entering the D block. And again, I can just move this stuff around. And if I cared to, I could in fact duplicate it. I typed Control C to copy, Control V to paste. And you'll see there's a bunch of other waveforms there. So you can make it as complicated as you might care to. Another interesting thing about SimSmith now is that you can do functions, and let's see if I can come up with a good one here. Here's some function blocks. Let me put this one in here. Actually, let me put it in here. This is called waves, and here's a function that I defined called waves. And I'll get rid of this. Okay, here's a function that displays the current and the voltage of whatever component I pass into it. So here I could say in the waves block, the function waves of L1. And there are the waveforms for L1, and you can build up libraries or functions which allow you to show different perspecti of components. You could also pass it components inside a RUSE block. That works just fine. And you can see down here that it says what component is the current, what component is the voltage, and that's because right here, whichever component is, we took the location name of that component and concatenated it. A plus is concatenation for strings with .i or .v and plotted it out. So there's some of the more sophisticated things you can do with a daemon block. It's useful for control, it's useful for plotting. The new plot commands allow you to write functions and like the scope and move things around. And so with a little bit of thought and a little bit of practice, you can build up control mechanisms and display mechanisms and put them in libraries so that you no longer have to remember or have to cut and paste. You can put them in a big daemon block, and of course this can be of any size, and build an environment that lets you spend all your time analyzing the circuit and understanding what's going on instead of driving. So there's a few things you can do with the advanced version of SimSmith, version 16.1. I hope this gives you some idea on the kinds of things you can do with it and how it can simplify your practice and your profession. This is Ward Harriman, AE6TY. Thanks for watching, and thanks for using SimSmith.